Welcome to a Graphics HyperLynx DRC training video. Today we will be discussing a DDR focused rule, the relative and delay length matching rule. Like all DRCs, you want to target the proper area of your design in order to get the most accurate violations and electrical rule sign-off for your board. In this case, we have DDR3 memory. There's 4 DRAMs in our design located in the bottom left corner, and they are routed to this FPGA U21. So I'm going to expand my rule group for DDR and the relative delay length matching rule and inspect the parameters of this rule. So this rule will check the skew or length of 2 nets in relation to each other. This is not to be confused with the delay and length matching rule. They are very similar, but the difference here with the relative delay and length matching DRC is that we are setting up 2 object lists to target our nets in our design. The first being the DDR DQ, and then we'll have them in relation to our reference nets, the strobe, the DQS nets. So the object lists that I'm checking against my reference are memory DQ lines, and I've set up another object list for the DDR DQS, which can be seen in the user's object list setup. If you're creating your own custom, you have to know your naming convention, and this is all explained in the object list overview video. But you'll create a new list and then call it DDR DQS, and then you'll add the electrical nets that are the strobe DQS nets from your DRAMs into there. So with all that said, I want to check the parameters here that I'm going to run on my design. First off, I want to check not just the skew, but I want to check both the skew and the length of these nets. And I've got my maximum allowed skew and maximum allowed length set. So now that that's all done, I'm going to execute the rule on the design. So I've got some violations here. And after going to the violations tab under the spreadsheet, I'm just going to select and see where my violations are, and then I want to read about them in the details window here in the bottom right. All of the information in the details window is also contained in the columns of the main window where you find the violations. The HyperLynx DRC makes it super easy for the user to find where in the design the violation occurs and give you proper details about the violation. So since we're checking for relative delay and length matching, we're checking skew. We want to know which nets we're checking against. So here we have our memory DQ15 being referenced to our DQS, in this case P0. And we see the lengths of each net and their length difference, and the delay of each net and the delay difference. Now if you're unsure of which one in the design of this zoomed in violation, the red is the violating net, so the red is the DQ, and the green is the reference net, which in our case, from the parameters that we set, is the DQS. So as you can see, HyperLynx DRC makes it very easy for the user to find where in their design their DDR3 or DDR4, depending on which one you set it for. In this case, this is DDR3 DRAM, and here are the DQ and DQS nets. If you use the output window, you can scroll over and indeed see that the violating nets here in green and red are the ones that we have discussed here in the window. Thanks for training with us today.